Okay, so the section 7.5 material is having us work with unit conversions. Now, our overall main idea with this entire section above anything else is we're going to be converting a number from one unit into different units. So I'm starting with yards, I want to convert into feet. I'm starting with miles, I want to convert to inches. I'm starting with seconds, I want to convert to days, miles per hour to feet per second, things like that. So I have found that with this material, a lot of people have the knee-jerk reaction of just wanting to go and do a whole bunch of multiplication and division right from the get-go. And what I'm going to invite you guys to try doing today is something different from that. But I think it does a lot of the prep work for us in determining, do I multiply by this number? Do I divide by this number? And keep track of where we are along the way in a problem really, really well. So I think it's a little bit of a shell shock up front with how we go about doing this, but I think by and large it becomes pretty darn useful and really efficient later on as well. So the suggested process, and I will say that there's a few ways you can display this for yourself on your paper, and it's isn't really a very descriptive way of writing it out, or at least it's not going to make as much sense until we get into the examples. So what we are going to do is we're going to basically be multiplying a measurement by one over and over again. So the idea behind this is because we are just converting something from one value into another, or from one unit into another, I'm not actually going to change the underlying value. I'm just changing what unit it's depicted in. We can think of this in terms of dollars and cents as a really good tangible example. I have $1, or I have 4 quarters, or I have 10 dimes, or I have 100 pennies. It's all the exact same amount. I'm just converting between which unit I'm working with. So when we are going through and using this unit conversion process, we are effectively going to be multiplying everything by one, albeit we're going to do that in a really weird way, specifically to create things in new units that we're looking for. Now, again, a lot of this is going to sound really weird and kind of, okay, that's a thing, but how do I actually do this and use this? And we're going to have a couple different methods for organizing this first step for ourselves. When we are working with this process, especially when we have multiple units that we are converting, which we're going to see is going to be in a lot of these problems, I recommend that in this setup step for ourselves, we do not do any multiplying or dividing at all. We are going to let the calculator do a ton of the actual number crunching and heavy lifting for us, but way later in the problem after we have everything set up and all the numbers where they need to be. So we know, hey, I'm multiplying this number, or hey, I'm dividing this number, and we can take care of it from there. And the last part I do want to mention here, if you guys do have the geometry formulas page, I believe I gave this out to everyone at one point in time. Maybe I didn't, and I do have copies of it. So when I return in person, I will give you guys copies with this. We do have on this front page just a whole bunch of geometric formulas. We will be using these in chapter 9. But the one we want to look at is right here, the measurement help sheet. So when you guys are going through problems on the homework or otherwise, this is the main set of stuff that we are going to use. I think as I'm seeing it, okay, yeah, it's actually just hidden right over here on the back side of these notes. So same material, just copy pasted a portion of it over. When you are going through and working through problems on the homework, my recommendation is that you use these notes and these specific conversions that are listed here. When you guys are going to be tested on this material, because it will be showing up on a test, I will be providing you guys with this set of unit conversions. There's a distinct possibility that I will be just basically giving you guys this right-hand sheet that we have here for the test itself. And you guys can use all of this. You don't need to write it on a note card or anything. You'll just have access to all of this here readily available to you on the test. Now, to that point, I recommend to everybody that, as best you can, try committing this top set of units and conversions. Try committing those to memory as best you can. Those are the most common conversions that we end up seeing with a lot of problems, and I think it's good to have those memorized. I think thankfully most of us should be good with the time ones that we have here, but the ones with inches, feet, miles, things like that, those are also pretty common ones that we see showing up here. So just want to note this to everyone that when we are going through and working through some of these problems, these are the units that I am going to be referencing and the conversions that I'm using and numbers that I'm plugging in. So again, as best you can, I would say screenshot the document, download the document, whatever you would need to, but this is what you're going to be using, and I'm expecting you guys to be using for the homework and on the test as well when we get through and work on these conversions. Well, let's go ahead and jump on over to a couple of our examples. And I guess since I have the main things listed here, I'm going to just delete this page to give myself some space. Okay, so we're going to go ahead and take a look at our very first example here. How many seconds are in 1 day? If you need to, I would leave this here just for a second. If you guys would like to take a quick screenshot of this just to get, here's all the problems or anything like that, go for it. And then we'll start working through these off to the side. Okay, let's go ahead and pan over here and we'll start with number 1. Again, all the examples I'm going to be going through and listing, they're just coming directly from the notes, not making anything else up. So you guys can access this later as well. So number 1 is asking us how many seconds are in 1 day. Now the process that we have and the way that I recommend that you guys go around solving these problems is starting with this. First and foremost, write out the number and the unit that you are starting with. So we're starting with 1 day. Now, what unit or units are we converting into? Well, I'm starting in days and we're asked how many seconds are in 1 day. So I'm starting with days and I want to end in seconds. I think this is pretty straightforward, but very, very useful at the beginning of a problem just to say, what am I aiming towards? What should I be ending up in with all of these? So I think it's a good starting place for every single one of these conversion problems. Now we have 2 ways that we can go about writing this out and organizing it for ourselves. One of them, and the one that I personally like using, involves the use of fractions. The other one is, I've heard it referred to as the railroad track method or the train track method. It's just a different organizational pattern. I don't care which of them you would like to use. I'll show you both, but they're really similar in how they operate. So with making fractions, starting off here, you always want to start with the number and the unit listed in our first fraction. Now with this one, we're working with days. So do I have any unit that's showing up in the denominator at the very beginning? No, I don't. So I can just leave this denominator as a placeholder 1. I'm going to start with 1 day over 1 for my first fraction. Now, I want to try and take a look at the chart that has been given to me. And in a perfect world scenario, we are looking for a direct days into seconds conversion. And I'm looking at here, the only thing I have is days to hours. So I don't have a direct days to seconds conversion. That's okay. That generally tends to be the case with most of these problems. What we want to do instead is say, all right, I'm starting with days. Can I convert days into a unit and then that unit into another unit and that one into another one and so on until I eventually end up in seconds? And it looks like we can do that. We can convert days into hours, then we can go hours into minutes, and then we can go minutes into seconds. So I'm going to do 2 or 3 steps to get to my final answer with these conversions, and that's perfectly fine. That's expected. That's what's going to happen with most of these problems. So let's go ahead and get that set up for ourselves, and then we'll let the calculator do a bunch of number crunching for us later. So I'm starting in days. I want to end in seconds, but I need to go to different units along the way. So if I'm starting with days, the unit of days in my numerator spot, and I want to cancel that out and convert that into hours, I need to have two units set up in my next fraction, days and hours. If days is currently in the numerator spot and I want to cancel that, then I need to put days in the denominator of my new fraction. Remember with fractions in cross-canceling, I need something to be the same in the numerator and the denominator for things to cancel out. So I have a day unit up top, I have a day unit down below, and these will be able to cancel for me. I can now fill in some numbers here. I know that one day is 24 hours. And again, we're just grabbing that from the chart or common knowledge, either one. And what's nice about this is now that I have days up top, days down below, I can cancel these things out and just note now I'm in the units of hours. Okay. Not what I want to end up in for my final answer, but I'm closer to it. So I want to convert hours into minutes. If hours is currently in the numerator spot and I want to cancel it, then in my next fraction, I need to put hours in the denominator spot. So I put hours down below, and I can put minutes up top and then fill in numbers. I know 1 hour is 60 minutes. I can then cross off units. I'm now in minutes, not seconds, so I still got an extra step. That's fine. Minutes is currently in the numerator spot. I need to put minutes in the denominator spot in my new fraction to have them cancel. Oops. Make that a better, there we go. And I know that 1 minute is 60 seconds. I can cross off my minutes units because they have cancel. Whoops. It's not letting me change the colors. There we go. Maybe. That's taking its sweet time. We'll cross them off like this for now. Oh, there it goes. Okay. So now that we have all of these previous units canceled out, I'm now in seconds. This is what I want my final answer to be in. Awesome. I think it's pretty helpful to put maybe a star over this or maybe circle seconds to say, hey, this is what I wanted to end up in. I am completely done with setting this problem up for myself. We might look at this and say, well, yeah, but there's a whole bunch of gross numbers in here now. I need to do a bunch of number crunching and all of that. And yes, that's correct. We have to do that. But we are not actually going to do that. We are going to let the calculator do all of that for us because we paid good money for that thing. So let's have it do some actual work. Now, the way we multiply fractions, going back to our previous material, I multiply fractions straight across. So I'm going to multiply everything in the numerators together. And I'm doing that off screen because I don't know what that is off the top of my head. It should be really big. So 1 times 24 times 60 times 60, and I'm getting 86,400. For my denominator, I just have 1 times 1 times 1 times 1. So I get 86,400 over 1, which we can simplify down. Let's just take the fraction, get rid of that implied stuff. We have our final answer of 86,400 seconds. And there would be how we convert days into seconds. Again, this is just one way that you can set up and organize this for yourself. There are multiple routes that you could take. I've seen other people use methods that aren't fractions or aren't the railroad method, which is what we're going to go through next. But I think doing something to set this up for yourself goes a really long way with these problems. So I'm going to go ahead and jump to we'll do number 2 for this. So number 2 is asking us, how tall in feet was the tallest man on record, Robert Wadlow, at 272 centimeters? Okay. So we'll start with this, and let's write down the relevant starting and ending information, give ourselves our framework. So I'm starting with 272 centimeters. So let's make that a better M. There we go. Now, what unit do I want to end up in? Well, based on what the problem is saying, I want to end up in feet. So I'm just going to note 272 centimeters, and I want to convert this into feet. So that's what we're going to end up in. That's what we're aiming for. We'll see if we can do that in 1 step or 2 steps or 3 steps or however many it takes. That's fine. So with number 2 here, I'm going to go about showing you guys an alternate way you could organize this for yourself. It's very similar to using the fractions, but this is, I've heard it referred to as the railroad method, or the railroad track method. So instead of having multiple fractions, we're just going to make one big old line in here. We're still going to work with units and numbers up top and units and numbers down below. We're just going to have one big line versus multiple smaller fractions in there. So I'm starting with 272 centimeters, just like we did before. And then we're going to put that over just a placeholder 1. I don't have any units in the denominator spot, so putting 1 here is not a problem. And then we can put a vertical line here to show, hey, here's just this bit of information. Now we can take a look at our conversion chart and say, do I have a direct centimeters into feet conversion? I'm going to go ahead and move over and go down to that. And again, centimeters into feet, that's what we're looking for. And I'm not seeing a direct centimeters into feet conversion on here, which, hey, that's fine. Kind of how it tends to be. But I'm noticing that I could go from centimeters into inches, and then I could go inches into feet up here, which that seems reasonable. Let's go ahead and use that. So we'll go and take 2 or 3 steps to convert these units over. So I'm starting in centimeters, and I want to convert centimeters into inches. So I currently have centimeters in the numerator spot. If I want to cancel that, I need to put centimeters in the denominator spot of my new bracket that I'm going to put in, or my new chunk of this. So I have centimeters down below. I'm going to have inches up top. I can then fill in the numbers, and based on the chart, I'm told that 1 inch is approximately 2.54 centimeters. Again, work with what the chart that I've given you tells you to work with. That's what I'll be using for the test. If you were to Google and look some of these up, they might give you some slightly different numbers. Yeah, metric to imperial is a little weird with that conversion. So that's why I'm just saying for now, just use the chart that I've given you. That's what I'll be using as we're going through the tests and everything like that. So I was in centimeters. I now converted over into feet, which is awesome, or inches, I should say. Apparently it's not going to let me change colors as much, so that's fun. All right, it's going to be glitchy. All right, so I'm now in inches, and I have an inch to feet conversion. If inches is currently in the numerator, I need to put inches in the denominator spot. And I can put feet up top. I know that 1 foot is 12 inches. And now my inches units have canceled out. And I'm now currently in feet. And that's what I wanted to end up in. So great, I have the rest of my setup all taken care of. I have everything that I need. I can kind of forget about the rest of this stuff over here if I wanted to. Go ahead and erase that just a little bit. And maybe, whoops, wrong one. There we go. Make it a little bit nicer to work with. There we go. So we cross these ones off here. We are now in the unit that we wanted to. And what's great about this, now you don't need to worry about, hold on, do I multiply by 2.54? Do I multiply by 12? Do I divide by 1 or the other or anything like that? This whole thing right here does the setup for you. So you don't need to worry about multiplying by 1, dividing by 1. We just treat this like a fraction. multiply everything up top together, multiply everything down below together, and then just deal with what's left over. So in the numerator spot, 272 times 1 times 1, well, that's just going to stay as 272. And then if I look at the denominator spot, I'm going to have 1 times 2.54 times 12. And again, do that on a calculator because that number is probably fairly big or a little bit gross. Okay, so for my denominator, I'm getting 30.48. I'm still in feet. Okay, we don't really like having fractions for this if we can. We generally like working with unit conversions in decimals, and the directions said round to the nearest thousand. So let's go ahead and do 272 divided by 30.48. And okay, it's going to be a big, gross, terrible decimal. I'm getting 8.9238884, and then just a whole bunch of extra stuff showing up there. Still working with feet. So we are told to round to the nearest thousand, which means I'm rounding to 3 decimal places. So this 3 is the thing that's eligible to be rounding up or down. The number to its right is 5 or more. So I'm going to get 8.924 feet for my final answer. And when you're going through these on the test, I'm testing you guys on them, I will be specifying round to the nearest 100,000, things like that, so you will not need to guess at that. If you're going through the homework and you're unsure what to do for rounding, again, I would say default to 3 decimal places. That's your best bet as you're going through them. So we have our 2 methods for setting these things up and organizing them. I personally like to use fractions. I think the parentheses, for me personally, help keep these things separated a little bit more easily. So I can see here's the first conversion, here's the second conversion, here's the third, and so on. But some people really like to use the railroad method for organizing it as well. I do not care which one you would like to use. I would just pick one and commit to that as you're going through these problems. Either one will work though. So let's go ahead from here and we're going to jump to question 4 because I think that's really going to start highlighting where multiple units come into play, multiple conversions are showing up, and these 2 organizational methods get to shine. So looking at number 4, we are told to convert 75 miles per hour. Whoops, what is it doing? Apologies. We are told to convert 75 miles per hour into feet per second. Okay, so we will start with, once again, just writing out for ourselves what's the number in unit we are starting in. 75 miles per hour, and we're converting into feet per second. So the buzzword per in there denotes that we have a fraction, something based on something else. So that means we're going to have a unit in the numerator spot and a unit in the denominator spot. Miles needs to convert into feet, and hours needs to convert into seconds. Now, this is the prime example, and we'll see several more of them as we're going through these other ones. This is the reason why I recommend using one of these 2 organizational methods. When am I going to multiply by a number versus divide by a number? Because I have stuff that's going to be showing up on the numerator and the denominator as I go through this entire process. When do I multiply? When do I divide? I think are perfectly normal questions. And if you are not using either of these organizational methods, you get to basically guess at that. And I don't think any of us want to be guessing at math if we can help it. So we're going to go through and get this thing converted. I'm once again going to use fractions as I'm converting these things for my units and everything like that. But you are more than welcome to use the railroad method if you would like to follow along and go through this. And if you are doing that, I would just encourage you to say, all right, slightly different what we're doing. Let's see if we get the same answer. Now we have a choice that we need to make here. There's no right, wrong, better, or worse. We just need to pick something and commit to it. Do I want to convert miles into feet first, or do I want to convert hours into seconds first? It truly doesn't matter with any of these problems. Just pick which unit you want to start with and commit to it. So I'm going to choose to convert miles into feet first, and then I'll deal with hours and seconds later. So for miles, miles is currently in the numerator spot. I want to cancel miles, so I need to put miles in the denominator of my new fraction. And I do have a miles to feet conversion. We're looking at the chart. 1 mile is 5,280 feet. Let me check that on my other screen so I'm not giving you guys wrong information. Yep, that's what it is. Okay. Have that there. I can cross off the units for miles, and I'm now in feet, which is excellent. That's what I want my numerator units to end up in. I can put a little star up there if I want to. I think that's generally helpful to say, hey, my numerator's in the unit that I want it to, and the star makes that stand out a little bit more. Apparently OneNote is not letting me change colors very easily, so see if we're able to. Okay, we'll leave it this way. So miles to feet has been converted. Good to go there. I can now ignore any and all the units that I have and all the work that I've done up until now. I will deal with the numbers later. I now want to convert hours into seconds. So everything that I've done up to this first star is just going to sit here. It's not going to affect anything else with the hours to seconds conversion. I'm starting with hours, and I don't have a direct hours to seconds conversion, so I'd have to go hours into minutes and then minutes into seconds. Hours is currently in the denominator, so I need to put hours in the numerator of this fraction, and I can convert hours into minutes. 1 hour is 60 minutes. Hey, there, it's letting me cross it off now with different colors. So hours is canceled out with hours, and I'm now in minutes for my denominator. Not what I want to end up in, but I'm along the right path. So minutes currently, if minutes is in the denominator spot, I want to cancel it, which means minutes needs to go in the numerator up here. Minutes up top, seconds down below. And I know 1 minute is 60 seconds. And I can cross off my minute units. My denominator, if I'm looking at my units down here now, my denominator is in seconds. That's what I needed to end up in. I put the little star there again. That's helpful. And fantastic. My numerator is now in feet. My denominator is now in seconds. Feet per second is what I wanted to end up in. I have my entire setup ready to go, and I don't need to do any number crunching along the way to get this to this point. Now we let the calculator come in and do all of the heavy lifting for us. And then once again, just going to multiply all of the numerators together and then multiply all the denominators together. I'm getting to 110 feet per second, my final answer. So again, I think this is the big advantage of doing this organizational pattern. Again, whether you're using the fractions or the railroad method, you don't need to figure out if you're multiplying or dividing by a number along the way. You also don't need to keep track of each unit change and each number change along the way as well, because you need to otherwise say 75 times the right number divided by the right number divided again by the right number. And am I writing that out properly or not for myself? And I think there's a lot of room for error to show up if you're trying to track and do all of that in your head and do the number crunching along the way. So fight the knee-jerk reaction of wanting to crunch numbers as you go through the problem. You're going to let the calculator do all of the heavy lifting for you at the very, very end. You're just getting it set up for yourself and the calculator to do so. Let's go ahead and jump over to, let's do number 6. I'm bringing in a little bit weirder units, but that's fine. Not every unit's going to be conventional. So number 6, we're told to convert 33 cups per second into gallons per minute. Okay. So we'll go ahead and write that out for ourselves. Again, I think it's very good practice to start off with writing what's the number and unit that I'm starting in. In this case, 33 cups per second. And what am I ending up in? We're told to convert that into gallons per minute. So we'll do gallons per minute. Okay. Excellent. And once again, like we did with the previous problems, we're just going to set this thing up for ourselves and convert one of these units at a time, get the setup for ourselves, and then number crunch at the very, very, very end. I'm starting off with 33 cups per 1 second. Now, the previous problem, I converted cups into gallons first. I'm going to arbitrarily switch that up, and I'm going to convert seconds into minutes first, just for the sake of showing you guys that you can do it multiple ways or in either order, and it won't matter. So going seconds into minutes. Seconds is currently in the denominator of this fraction. If I want to cancel the unit of seconds, then I need to put seconds in the numerator of my next fraction. So I have seconds here. I'm converting seconds into minutes. Minutes goes down below. And then I can fill in the numbers. 1 minute is 60 seconds. My seconds cancel out. I'm noticing, okay, now my denominator is in minutes. That's what I wanted to end up in. Perfect. I can put the little star there, say, hey, great, the denominator is done. It's taken care of. I don't need to worry about those units anymore. Now I get to worry about the numerator. Going from cups to gallons. I'm looking at the conversion page that I gave you guys. I am not seeing a direct cups to gallons conversion. So we might need to do a couple steps along the way. What I am seeing is that there appears to be, and it's in the second-hand column, 2 cups into pints, and then I can go pints into gallons from there. So that's what we are going to use. So with cups, starting with cups in the numerator, I want to convert cups into pints. So cups up top. To cancel it, cups needs to go down below. I have cups into pints. Fill in the numbers. I know 1 pint is 2 cups. Again, just getting these numbers directly from that chart that we have. And then I have a conversion of pints into gallons. I can write that in. If pints is up top, to cancel it, pints needs to go down below. So pints down below, and then I can put gallons up top. And I'm told that 1 gallon is 8 pints. I can cross off the units that canceled out, and my numerator is now written out in gallons. That's what I wanted that to be in. I can put a little star there. I've got my numerator where I want it to be. I've got my denominator where I want it to be. Fantastic. I have everything set up for myself. Now I can actually start number crunching. So let's go ahead and rewrite this into a single fraction, and then we'll convert that fraction into a decimal afterwards. I'm getting 123.75 gallons per minute as my final answer. Let's try and get the whole setup in here. Yeah. So I'm hoping that we're seeing the value of doing this setup process. And again, I'm using fractions. You are welcome to use the railroad method if you would like to. Both will work, both get you to the same point. But doing this organization means that you don't have to worry about what number am I at along the way? Have I converted everything correctly along? Well, Want to make sure we're converting along the way, but is my number rounded properly along the way or not? Or do I divide this number, multiply a number? Because I think as we're seeing now with examples 4 and 6, there's a lot of potential guessing room for multiplying by something or dividing by something. And if we're not following some sort of a setup for ourselves, I think it's much harder to figure out. So with that, let's go ahead and take a look at, let's do number 8. Why not? We've been doing the even ones. Let's keep doing that. Number 8 is telling us a turtle crawls at 24 inches per minute. Convert this into feet per hour. Great. Let's go ahead and get this thing set up the same way we did previously. We'll try doing this one with the railroad method just to show that we can still use both. Again, we want to start off with what's the number and the units that we have been given originally, and what am I going into? So 24 inches per minute. I'm converting this into, what did it say? Feet per hour. Perfect. Making that note for ourselves. Now we can go through and get this thing set up and go from here. So again, I'm going to use the railroad method for this one. Again, just to show that we can use it, but you're welcome to use either method to solve this thing out. So I have 24 inches for every 1 minute. We'll divide that up there. Once again, I need to determine if I want to convert inches into feet first, or if I want to convert minutes into hours first. Does not matter which one we choose. We just need to pick one and commit to it. So I'm going to go ahead and do inches into feet. It seems like that might be a bit more straightforward. So we'll just do that one first. If I have inches up top and I want to cancel that unit, inches in my next one needs to go down below the denominator spot. And I can fill in 1 foot is 12 inches. And I can cancel some units out. I'm now currently in feet in my numerator, which is what I want to end up in. I'll go ahead and put the little star there just to note, hey, I've got this one good to go. We're ready there. Now I need to convert minutes into hours. So I'm starting in minutes. I need to convert that over. So if minutes is in the denominator spot and I want to cancel it, minutes needs to go in the numerator spot for my next problem. I'm putting minutes up top. I have a minutes to hours conversion. 1 hour is 60 minutes. I can cross off the units that I'm canceling. And I'm now in hours in my denominator spot. That's what I wanted to end up in for my denominator units. I can put a little star there. And fantastic. I have everything set up for myself. I don't need to do any other things on the very end here. I can multiply the numerator together, multiply the denominator together, and then just simplify the result. I'm getting 120 feet per hour as the result here. Hopefully you guys are getting the same thing. And again, you're welcome to, and I encourage and am expecting everyone to be using a calculator to get to these numbers here and then the numbers that we're getting for our final answer as well. I think that's perfectly reasonable considering these can get pretty big pretty fast. Okay. Number 10. So we're told a faucet leaks at a rate of 2 cups per minute. Convert this into gallons per hour. All right. We'll once again do our setup we did before. So we have 2 cups per minute. And we want to convert that into gallons per hour. Excellent. So again, I'm going to use the railroad method with this one just to show kind of an even spread of both methods working on the homework or on the test. I do not care which one you would like to use to organize this thing, but I would recommend picking one and committing to that for that particular problem. So using the railroad part here, I have 2 cups for every 1 minute. Okay. Now again, I need to determine, do I want to go minutes into hours first or cups into gallons first? Doesn't matter. We just need to pick one and commit to that. I'm going to arbitrarily do minutes into hours because I think I did the reverse in the previous problem. And that's the level of decision making you get to make. And that's the level of, I don't know if you want to call it pettiness, but we could call it pettiness for, that's the reason I want to pick that one. So if minutes is down below in the denominator spot and I want to cancel it, then minutes is going to need to go in the numerator spot to cancel out. So I'm converting minutes into hours. I know 1 hour is 60 minutes. Now I'm checking, is my denominator in the units I wanted to end up in? Yes, it is. Awesome. I can put a little star here just to denote, hey, I've at where I wanted to, met my goal there. Love it. Now I get to convert cups into gallons. So I'm starting with cups, and I don't remember if there was a conversion. Oh yeah, cups to pints and then pints to gallons. So I got to do a couple steps with this one. That's all right. We expect that with these problems. So if cups is currently in the numerator spot, and I want to cancel that, then cups is going to need to go in the denominator spot down here. And I'm told, just bringing from the paper, I'm told 1 pint is 2 cups. And cancel a few things out. Now I'm in pints. This isn't what I want to end up in, but I'm at least closer to it. I'm looking at that page and I'm seeing, oh, I've got a pints to gallons conversion. I can use that. So pints is currently in the numerator. So I put pints in the denominator down below here to have it cancel out. I want it to end up in gallons. And based on the chart, I'm told that 1 gallon is 8 pints. And cross off the units that I'm canceling out. And I'm now in gallons. And that's what I wanted to end up with in my numerator spot. So I can put the little star there or circle those or do both. But now I have gallons per hour. Everything is set up for myself. I can now go ahead and do some number crunching in the calculator. And let's see what we get for our answer down below here. And I'm getting to 7.5 gallons per hour. So this is a pretty good summary of the process that we're using. I'm hoping that everyone has seen that this is extremely repetitive in terms of how we set this up. It, again, does take the discipline of saying, I'm not going to do number crunching along the way, and I am going to actually write out and cross out and have some discipline in setting up my units accordingly with this. However, what I tend to find that if you are doing that, these sorts of problems, these become way, way, way more easy to work with. There's way less guessing involved, and you get to the answer way more reliably, and I think more quickly over time. There are obviously some conversions that you're going to be able to do in 1 step or 2 steps, and you might be able to do those in your head. Great, awesome, nothing wrong with that, but they are not all going to be like that on the homework, and they're not all going to be like that on the test. So in terms of the scratch work that you could be writing out, something like any of the examples that we have here, I'm going to try and zoom it out so you can see all of them. Something like the scratch work that we have here is perfectly good and fine in my book. I'm happy with this being what I see on the test. And to that point as well, for the material that I could be testing you on, the questions like we went through today and are listed in this set of examples, this is the full extent of the difficulty that I could ask you guys to go through these problems. And again, I am planning on giving you guys this unit conversion chart to use on the test. So you will not need to have this in your notes and just need to know how to work with and reference this as well. I'm seeing something in the chat here. Give me a quick second. I want to zoom this out for everyone, and then we'll take a look at that. Cross cancel the numbers like 2 cups, cross cancel 2 cups or just units per. Yeah, so great question with that one. You can, like I think if we're looking at so for cross canceling with these, a couple examples and maybe where this is showing up. If we're looking at the 12 and 60 here, if we're looking at 2 cups and 2 cups here, if we're looking to cross cancel along the way and do that early, you absolutely could do that if you would like to. However, you do not have to do that because all of this is eventually going to combine together to just be one fraction and then convert to a decimal at the end. So can you cross cancel the numbers early like we do the units? Yes, and that is completely fair game to use. You might end up making more work for yourself in doing that than just saying, I'm going to let the calculator multiply the numerators together, multiply the denominators together, and then just divide the final answer there. So it is an option. It is not wrong. You are welcome to do that. But at the same time, you don't need to make more work for yourself if you don't want to. Does that clarify that question? Perfect. Yeah, great question with that. A lot of people want to do that with these problems, and I don't think there's anything wrong with it. I just lean into the part of make life easy for yourself. You don't do extra work if you don't have to. Yeah, here it is. Your math teacher saying be lazy in math class and don't do extra work. In the best way possible, though, I think. Okay, so with that, that's I think a good solid setup for this material. Otherwise, we're just going to be doing the exact same stuff over and over again. And again, this level of difficulty for these types of questions and the numbers and things like that, this is the extent of how difficult I'm planning on making it for the test, and have the necessary material available for you with that as well. So I'm going to go ahead and end the recording here. Then I'll take any questions that you guys have over this material or anything else that you would like to go through.